Hey Physical Geology, I wanted to make a quick video that kind of illustrates how you go about completing some of these operations in Google Earth. So I'm just going to double click the example place mark that I created for you. And this video is just going to show you how to measure the length of roads, how to estimate elevation for streams, and how to measure the length of a stream. So whenever you double click on a place mark, which is usually a KMZ or a KML file, it'll take you directly to a location that you're supposed to be looking at. And a lot of your questions ask you to use EarthPoint Topo Map in that overlay. So that's provided for you on the web page, but then also I want you to see how, once you use it a couple times, it'll stay automatically in your Google Earth places. Like as you can see, I'm on Google Earth a lot, so I have lots of different places here. But when you click that on, what it will do is it'll take a second, but it will overlay topographic maps right in the area that your place mark takes you to. So what's kind of cool here is, so you can see here's a swamp is illustrated by this little symbol on the topographic map, and when you turn it off, like that, you can see that the swamp is like the sort of wooded area, which is because it's swampy and so no one can really use that land the way it exists right now. You can see main roads, you can see this sort of slinking feature here. It's probably going to be a stream when we put topo point back on. Yep, you can see that's Black Creek right there. And so without the topo layer, what you can see is what's called the Riparian Corridor, which are like the trees that surround the stream on either bank. So this is your Google Earth example. I'm just going to show you a couple different things that you can do in Google Earth, all using this ruler tool pretty much. So the ruler tool has a couple options here. For measuring straight lines, you're going to use this line function. For measuring a path, a winding path like a stream, you're going to use the path function. We don't use the polygon function in 101, but it's actually a really cool way to estimate the area of a place. You will be using the circle function in seismology, in your seismology lab, so you'll worry about that later. And we're not going to do the 3D path or the 3D polygon. A really important point here is make sure that mouse navigation is off. If you have mouse navigation on and you're trying to measure something, it will just kind of move Google Earth around, which is not what you want to do. So I'm going to hit escape here, and I'm going to turn mouse navigation off, and I'm going to clear everything there. I also want to make sure that I'm in the right units. So this is going to measure something on a map, and we in general want to measure things in miles. If you're looking for a good time, you can read about what a smoot is. It's very nerdy. It is not an actual unit of measurement that anyone uses, but there it is. So we're going to select miles, and I'm going to have you measure the length of, in this example, I'm going to measure the length of this road from where it begins here at this little Y to where it ends on this road in Riga. So what I'm going to do is, you'll notice that my cursor has turned into a box. I'm just going to click the beginning portion. I'm not holding down the mouse. I go to where the road ends, and then I click again, and that will give me the length of this road. This road is a little bit more than 1 mile. Okay, so that's how you measure the length of straight lines. Not everything in life is a straight line. So when I'm done with this, I'm going to clear it out, and maybe I want to measure, I guess first I'll measure this road, the length of Robertson Road. That's not a straight line. Anytime you're measuring something that is not a straight line, you're going to use the path function. And that again will turn your cursor into a box, and you just kind of move along, and you trace it out, and you don't have to be perfect, but you don't want to be crazy about it either. And this way, we measure that Robertson Road is about 2.2 miles in length. When might you be measuring something like that? You might be measuring a curved surface when you measure the length of a stream. So streams are illustrated by this blue line. The other thing I want you to notice is that Google Earth allows you to zoom in a lot. Eventually it'll get sort of pixelated as you get to about this point. But this is definitely closer than you could get to a topographic map if we were in class. Also give your computer a second. You notice that mine took a second to resolve there. One of the things I might ask you to do in class is to estimate the elevation, or to estimate a stream gradient of this river. We'll talk about stream gradient in just a second, but one of the things you're going to need to know is the length of the river. And I might ask you to measure the length from where a river starts to maybe where it crosses Robertson Road. So here's that blue line that represents the river, and I'm just going to do the same exact thing where I'm holding down my mouse button and I'm just tracing out. And again, I'm not being perfect, but I'm not being sort of crazy about it either. The length of the river, and I pick up my finger from my mouse when I'm done, and I see that this stream is about 1.2 miles. So that's important information that, let's say, I write down. Okay, so I want to estimate now maybe the elevation. So stream gradient, I'm not quite sure I know I'm going to do this. I'm going to pull a little Word document over as well. And I'm going to minimize it and drag it over to this screen. Okay. So when I'm measuring a stream gradient, basically estimating if I walk a mile up this stream, how much has my elevation changed? So really any gradient, because a gradient is just a slope, is calculated by taking the highest elevation, whoa, even spelling it right, in feet, subtracting it from the lowest elevation, or the lowest apparently, lowest elevation, and then dividing the change in elevation that I see there, whoa, I'm going to divide that number, but not with an underline, by the length of the stream, or however much if I'm looking at a hill, the length of the hill in miles. The change in elevation is going to be in feet, and then the length will be in miles. So to calculate a stream gradient, I have to first estimate what the highest elevation is here. So I'm going to close my ruler because I don't need that right now. And I'm going to zoom in here. One of the things that you'll notice is that not all of these contour lines are the same thickness. You'll notice that there's some that are darker, and then there are some that are a little bit lighter in color. The darker contour lines are called index contours, and they're always labeled. And that's useful when you're trying to figure out what your change in elevation is, or your contour interval between contour lines. Sometimes when an area is really gently sloping, what will happen is the USGS, which is the government organization that makes these maps, what they will do is put what are called spot elevations on some of those contour lines. But in general, you're going to see contour lines for these darker index contours. And you'll notice that in general, especially in this particular map that we're looking at, that the contour lines, you have this dark contour line at 600 feet above sea level, and then the next contour line that you see is 650 feet above sea level. So these occur every 5 lines. Index contours occur every 5 lines. And that you can use that to kind of figure out what your contour interval is here. So if we look here, you'll notice that just like there was 50 feet in elevation difference between my 2 contour lines between 600 and 650, there's also 50 feet in elevation change between these 2 contour lines between 650 and 700. And so you can use that to figure out that the contour interval in this map is 10 feet. So this is the 650 foot long contour line. This is the 660, 670, 680, 690, and then the 700 foot contour line. So knowing now, you can always, in your temporary places, kind of scooch back to exactly where you were taken by just double clicking on your name over here in places, and giving again your computer a second to put all the data back and all your maps back. So knowing now that elevation change is about every 10 feet, elevation change between contour lines is 10 feet, you can figure out roughly, it looks like this stream starts almost exactly on this contour line. So this is 600 feet, and swamps are in the lower lying areas, and we can see here's 550. We know that the numbers have to be going down between 600 and 550. So they go down to, or maybe that's 560. That's 560. So we go from 600 to 590 to 580. So if I go back to my Word document, my stream gradient equals 580 feet, and then I have to figure out what my lowest elevation is. So I scooch over here. So if this is my 580 line, this is my 570 line, and this looks like it's my 560 line, and here is my 550 line. I can see that it's darker, so that's good. That means I'm right about that. And we can't really see any contour lines between here and the road, and again it's getting pixelated. So we know that the stream here where it crosses the road, which is as far as we measured, is a little bit less than 550 because the stream is flowing downhill, and you can see actually that it flows into this larger creek right here. So we need to estimate a number that's less than 550, but it has to be below or more than 540, right? Because there's no other contour line here. So maybe we guesstimate for math that that it's 545 feet. And then again, we're going to divide that by the length of the stream, which we measured using that ruler, right? And we measured it to be 1.2 miles. So then we take our handy dandy calculator. I'm trying to be slick and I'm failing. Okay, so 580 minus 545 is 35 feet. And then we're going to take that 35 feet and we're going to divide it by 1.2 miles. And this I will use my calculator for, and remember to turn off the underline thing there. Okay, so 35 divided by 1.2 is 29, and don't worry about rounding here because you can leave it to the nearest whole number because we estimated both of these numbers, so it's all good. So 29 feet per mile. So what that means is if you were to hike up that stream a mile, you would move up in elevation only 29 feet. This is a really flat stream. When you're talking about streams in mountainous areas, your stream gradient will be several hundred feet in a mile. This is really flat, which is not surprising because we're in a swamp. So those are some of the things that you can do in Google Earth with your ruler tool. So you can measure straight lines, just to recap. You can measure straight lines with the line function, and regardless of what you're doing, turn off the mouse navigation. And you can measure the length of curved lines and curved features with the path function. All right, I hope that helps. Bye.